probably one of the more important aspects when we're talking about brain rules. So just as a quick recap, we'll kind of go over what we've learned already throughout the series. So in our first meeting, we learned about exercise and how that boosts brain power. And if we all remember the activity that went with this.
Jumping jacks.
Yes, they're encouraged, but not mandatory today. Later we learned about wiring, basically, and how everybody stores the same information in different places. And so each brain is unique and different. And so our neurons are constantly going through spurts of growth and pruning, and that is kind of the way that it's taught. And then our last meeting, we learned about attention, and that we do not pay attention to anything that's boring, and that multitasking is a myth. So today we're going to be talking about memory. And so memory is one of the most, I think, important aspects of what the brain does in terms of how we learn. Because as a species, we have been successful mainly because of our memories. Everything we've kind of been exposed to is basically something we've learned firsthand or secondhand. We've kind of had to be exposed to it somehow. And we've had to retain that information somehow. How do we do it? We will not be telling you all the secrets of that, but at least we will show you some of the tricks of how the brain does what it does. It's such a complex organ that we still do not understand it fully or entirely, but certain things have happened in the past that kind of give us an inkling into what memory, how memory functions. So our objectives today: active participants will be able to identify the stages of memorization, apply conditions favorable for storing memory, and evaluate how to make long-term memory more reliable. Does anyone know who this is? Okay, that's one person. Anyone else? Okay.
Yeah, the rain.
Yeah, so that was the actual Rain Man, Kid Peak. He died, it was 2008 or 9. So now he has one of the most remarkable memories that we've ever come across. He was born without a corpus callosum. If you remember in neuroanatomy, the main connection between the left and the right side of your brain, he was born without that. He also had cerebellar defects, and they didn't think he would actually ever amount to anything or become anything. They actually told his father, this is somebody you just want to probably put in long-term care and not too much about. But his father persisted with him. Didn't learn to walk until he was 4 years old. Now, the amazing thing about him, this is the real Kim Peek we're talking about, is that he spent most of the time in the library reading books. And he could read both pages at the same time with each eye. And he would remember everything he had read forever. Forever. He did not forget anything he read. And the important thing, again, is that he actually comprehended everything he read. So he wasn't just storing useless information. He knew the importance of it. And in context, he could actually give you back that information. So that makes all of us a little bit jealous. Like, I wish, that would really, really come useful and handy, at different times. So he was a very, very important, as a scientific subject. A lot of people dedicated their lives to studying his memory because it kind of informed us, how does memory work? What happens when new information reaches our brains? What is the brain actually doing with it? Is there any way we can improve our memories? At least kind of approximate his memory. I put up another subject here. Does anyone know who that is? Does anyone remember that movie? Okay, so if you remember that movie, then you kind of know where I'm heading with this. So this guy is called Henry Molaison. Now he was born, he started to suffer intractable epilepsy, lots of seizures, and different different techniques had been tried to try and ameliorate the seizures as well as they could at that time. This was in the 50s. So a neurosurgeon thought about a new procedure, and so he had a bilateral median temporal lobectomy. It worked. Seizures stopped completely. However, immediately after the surgery, he was never able to form any short-term memories going forward. He was never able to learn anything new. He would meet you now, and meet you for the first time 2 hours later, and meet you again for the first time 2 hours later. So he became also another important subject in the study of memory. So exactly what was happening. So what structures in his brain were actually removed? So it was basically, and we will touch more about this as we go on, the hippocampus on both sides, which kind of informed our understanding of why that structure is very important. Needless to say, that was the first and last time that procedure was ever performed. So he was a very important subject in understanding how we form memories. And this movie was not based on him, but was the closest approximation to kind of what it would be like to be him. It's kind of like Groundhog Day, but you're not Bill Murray, you're everyone else. You're just reliving the same day over and over and over again. This guy was trying to catch his wife's killer, but he knew he kept forgetting every time he woke up, so he kept leaving notes for himself to try and remember where he had stopped the day previously. So imagine trying to leave your life like that. It can be very, very hard. He had to learn his father died over and over again. So
50 First Dates.
yes. So exactly. I saw that one. I said. So he was another important subject in the study of memory. So as I said before, we are not going to be able to say exactly how memory works, but we can tell you some of the things that happen to make memory what it is as we know it. So with that, I'm going to. Okay, great.
And I'd like to lead off with an activity, because activities are always fun. What I want everyone to do is just take a look at these nonsense words. I'll give you about 30 seconds, and I just want you to try and remember them. We'll revisit it later. Okay, I think that's enough time. So I want to ask, what does everyone think a memory is? It's kind of tough to describe, right? So I want someone to try that. Is it something you've done? Past experience?
I mean, I think it's not answering the question, by the way. I think the like best memories are like associated with some emotional happening, or you know, a song or a smell or like something that
Sense.
yeah.
Yeah. And it could be like an image or an idea. So sometimes you could picture an experience or picture something. Other times you just remember facts.
Yeah, they related to senses, maybe like it's a smell or a picture or something that you experienced with one of your senses that comes back to you. So you have to have experienced it.
Do we think there are different kinds of memories? And if so, how would you break them down?
Well, there's the memory of like, I remember reading that article, but I don't remember what it said.
You remember that you forgot.
I think there's also memory, excuse me, in the sense of like the thoughts, kind of the visceral memory, but there's also the memory of like function. Like you get in a car and you know how to drive, you don't think about it. Or you get on a bike and you ride a bike, and that's memory too. So there's kind of, I think, the two kinds. There's like the emotional sensory, but there's also like functional memory.
Sounds like Jason wrote the chapter.
I did not read the chapter.
Okay. I'm going to skip ahead to the next slide. Different types of memory. In the 1850s, there was a German psychologist. His name was Hermann Ebbinghaus, and he classified two different kinds of memory. So the first is declarative memory. So I like to think of this as a Jeopardy game or any multiple choice exam where you are consciously recalling something. Your social security number, what you did last Tuesday, what you did in 1990, you're recalling something. But then, as Jason said, there's also non-declarative memories where if you're going to ride a bike, which is impressive that we both have the bike example, you aren't remembering this is where I place my hands, this is where I put my feet, this is how I propel myself forward. Your body is just doing that automatically, so there's no conscious recollection of your moment of learning, if that makes sense. And pretty much everything we do is thanks to memory. I mean, every time we talk, we had to learn words, we had to learn letters, we had to learn the English language. There's very little that we haven't learned, basically what we're born with. Moving on with what we know as far as the 4 stages of memory, as John touched on, there isn't a whole lot of hard science, but we can break it down into 4 stages. The first is encoding. This is the moment you learn something. Immediately after that, you have to store it somewhere. We don't know much about these 2. But then, at some point, we are asked to retrieve a memory, whether it's for an exam or something triggers a memory. But a lot of times, and always, we're eventually going to forget. Sometimes it could be seconds from now. You might have already forgotten what our objectives were for today. But you also might remember something that happened when you were 5 years old. So for encoding and storing, it isn't like you're filing something away in a cabinet. At our moment of learning, it's like an uncapped blender, where whatever you're processing is chopped up into a million pieces and scattered all across your brain. We mentioned in the wiring chapter about everyone has a different location of Jennifer Aniston memory. It's like that. And we know this because of a patient who suffered a stroke so specific that if you asked her to write a sentence like, "Your cat chased a dog," she would write what you see there. She could place the consonants. She knew what she wanted to write sentence-wise. She knew what it meant. She knew where the vowels were supposed to go, but she couldn't actually write the vowels. She didn't know what the vowels were. She didn't know A, E, I, O, U. So from this, we can tell that when we're encoding things and storing it, it's being spread very, very specifically in millions of different places in your brain. Something we understand a little bit better than encoding and storing is forgetting. We all know how much we forget on a day-to-day basis. And jumping back to Herman Ebbinghaus, one of his claims to fame is the forgetting curve, where he said within 30 days, his students would forget 90% of the material that he taught them in class. And the majority of that was very early on. Even minutes after hearing it, it would be gone. And this is kind of a callback to the game we played, because Herman Ebbinghaus designed that 3-word nonsense game. So I'd like everyone to try and write down as many of those 3-letter nonsense words as you can. We'll see how well it did. Lucas has 0. That's good. He's got 1. Did anyone get more than 5? Is everyone done writing before I show the answers? Are we still, Jason's thinking? No?
Do you guys want to stand up and like see who's in the third?
Well, I only have 6.
Okay, well, let's just confirm you have, is that right?
I have,
Oh, I
I
don't.
have Taslev, Pifker, Deck, Ian.
Okay.
Well, that's how I said them.
Anyone close to that?
I got 6, but I spelled heck wrong. I had H-E-P.
I only have 5.
Okay, so we have a couple people, 5 or greater. Anyone get 0 to 2? It's okay to admit.
No.
That's about half the room, probably next to nothing. So the people who got 5 or more, is there anything you did memory-wise, like any trick you did to try and remember? We've got a lot of different colors. We've got italics. Was there some memory trick that you used?
The Kerr was easy because it was underlined, right? That's the easy one. And the first one was first.
Well, when I was just looking at them, I knew I wouldn't remember them, so then I made them animals. Tasmanian devil, leopard, cur was a dog, even though it's not really. And again was Yinzer,
Yeah.
and then Griff and Deck stayed for some reason.
That's what I was doing too. I was thinking like SUV, but with the B, like a BMW SUV, or so I was trying to Jeg and Piff. I was trying to like remember them together, like JPEG and there's a Piff right there.
Yeah,
Yeah.
because the first
Oh,
you just
Jet.
saying
Oh,
them,
yeah.
and I was like, oh, they don't. Then the first two remind me of animals, so that's why I started there.
I'm the nerd of the group. I started with JEG's JPEG, and it was like, all right, well, deck computer, GIF instead of GIF. So I ran out of computer terms, so I only got 3 of them right.
I somehow remembered the bold black ones.
The gold black ones?
Yeah.
So it sounds like we had a couple different techniques to try and remember more. And Brain Rules goes into a couple different scientific bases for, that's a good point, trying to remember more tricks like what you just did. So the first one, I call it the same seat theory. Brain Rules doesn't call it that, but I like to think of a classroom example where every time you go to class, you sit in the same seat. Every time you're sitting in the same seat learning material, then exam day comes and someone's in your seat. It's not actually your seat, but you always sit there. The person sitting there thinks it's not a big deal that you just stole your seat, but you feel it's a big deal. So you sit somewhere else, you get an 80 on the exam. Interestingly, there have been a couple studies that show that there is a basis for sitting in the same seat. You can perform up to 15% better if you're repeating your original location and environment. They did a study where they took a bunch of participants to the beach, which sounds like the greatest study possible. They put them in the water and they had them memorize words similar to what we had done earlier. If they stayed in the water when they were asked to recall it, they remembered a certain number of words. But if they went to the beach, they remembered about 15% less. And if you're thinking maybe it's just specifically water makes you remember better, they reversed it where they had them on the beach for the point of memorization, and staying on the beach helped comparison to going into the water.
Greg, there's a theory, it's called propensity analysis that we see in the medical journals that is based on that philosophy. Just where you sit, there's propensity where people are attracted to. You think about where you are right now, it'll work. But that developed into a statistical model somewhere around 15, 20 years ago. I don't know if you guys remember, but propensity analyses is well known. I use it probably once or twice a month. It's a very strong technique. We're on because there's some affinity. We're going there.
And it is even true for things that you might think be negative. If you consume alcohol, consuming alcohol will help you remember better anything that happened while you're drinking. That's also true for laughing gas, it's true for marijuana, it's true for negative things that you would think hurt your memory. If you were doing something at that point, you remember it better in that initial state. And there's studies for that.
Well, it sounds similar to if you walk into another room to get something and you forget what it is you walked in to get,
You go
if
back
you go
to the
back to
original
where you
words, yeah.
started, for me, that generally works and I remember, because you have that physical memory too then of what you were doing when you had the thought.
So you're saying in the movie How High, based in fact,
I've not seen that movie.
Redman and some other rapper from the 90s.
Okay. Sounds good. On that note, let's do another game. Another word game. I want the left side of the room, so your left, not mine. I want you to close your eyes. Right side, leave them open.
Oh, I gotta do this.
Nicole and Teresa can decide which side they want.
I gotta keep my eyes open. Sorry.
So here are your instructions for the right side of the room.
Left side, closed. Closed.
Frank's gonna be there.
Good. Everyone can open their eyes back open. Open their eyes. Okay. Now it's the right side of the room's turn to close your eyes, while the left side gives instructions. everyone can open their eyes, I'll give you about a minute, maybe a little less. Okay. That may or may not have been related to our next point. We'll go back to those words in the future. But the final memory trick that I have for you is that we remember more if we are able to attach like those nonsense words to something more vivid, more complex, which is why we're all wearing really goofy outfits today. Hopefully you remember more. That's why a lot of the things in the slides have different colors on them, a lot of pictures. We hope that that is what you're taking away. Because the more vivid the memory, the more likely you are to retain it.
So we also don't pay attention to boring things, right?
So, kind of like to wrap up, we'll do that with a little bit of a story. And the meaning of that story, there was, I don't know if it's an urban legend or myth, but there's a university that just had their gardens done, the lawns were well manicured, fountains and everything was in place, but the contractors now wanted to put pathways and walkways for everyone, but the college president said, no, just leave it the way it is. So they were kind of frustrated, like, we need to finish the job. He said, no, leave it the way it is. So everyone just kept walking on the grass to the different buildings, walking wherever. And after a year, some well-formed paths began to form. And so it now became just grass with some dirt paths. And so those became the paths. And the college president called the contractors back and he said, okay, now wherever you see a path, that's where you should pay. And that's where everyone started walking because people use the most efficient ways to get from building to building. Now this video was a group of people over the 5-day period. They just walked the same paths over and over and over and over and over again. And it's an experiment. So it takes 5 days if you want to get a path. The reason why we bring this up is because whenever we're trying to, we talked about the first steps, what your brain does with memories. It kind of chops them up, slices and dices them, and throws them off to different parts of your brain. And so now, that's kind of counterintuitive to what we know memory is. Like a computer, this is the hard drive, this is where we store our memory, but our brain doesn't do it that way. It throws everything everywhere. So the neurons that respond to first pieces of information that you learn, they're kind of like your first responders, and then they go in, they take the information, and then they go back. Now, when that information is encountered again, that neuron responds again. Now, to be able to retrieve it properly, that neuron has to keep being stimulated, and so it's like beating a path into the grass. So you kind of have to repeat if you want to have success at remembering what you encountered for the first time. And that's essentially one of the things that the brain does. So which is why we say all that is new becomes one day old. It doesn't go necessarily somewhere else, but those neurons that first encounter the information, those are going to be the neurons that you rely on to keep this information more permanent. And so with that, that takes us.
Great. So how does short-term memory turn into long-term memory? The mechanism that guides this process is called consolidation. I like to start off by telling you a story, something that happened to me when I was about 8 years old. So I was all excited. First of all, when I was 8, I was really tall and skinny. I was very excited because I could ride roller coasters, right? That's all the exciting point when you meet that line where you can get on the roller coaster. And for me, so we went to a theme park with one of my friends, and I got on this roller coaster, and you pull the bars over, but the bars stopped here, compared to where I'm sitting, being skinny 8-year-old me. So roller coaster gets going, and it's going fast, and I start doing loops. Well, the bar's not being close to me, I start falling out. Yes, pretty scary. And so my hands are getting sweaty, I'm slipping down, I'm having my feet pushed up against the seat in front of me. Luckily, the man beside me sees that I'm falling out and holds me in. So this is a pretty emotional memory for me. And it's something I thought about for quite some time. But then, and similar to Winfrey's story, when he had us last time picture us riding on the bus and getting robbed, so it was a pretty emotional event that you're able to recall a lot of details with. Just thinking about it right now, my heart's starting to race. So, but other than that, I didn't really think about it until I returned to that theme park later when I was in high school with some friends. Luckily, that ride's not there anymore. It only lasted a couple years. I wonder why. And now, if you notice on roller coasters, if you've been on one, they go all the way down till it hits the end too. So there's not a stopping point on the seats too, which is good. But so what summoned my memory of this roller coaster? Well, how did I retrieve it? Well, research has told us when previously consolidated memories are recalled from our long-term memories, long-term storage, the consciousness, they revert to short-term, and this is called reconsolidation. So basically when we retrieve our long-term, we retrieve those memories, or those fragments of memories from our long-term storage, they kind of revert back to short-term memory, and the pieces start filling in, and then that memory goes back to our long-term memory. So how does this happen? So like working memory that we talked about, there's different kinds of long-term memory. However, unlike working memory, not much is agreed upon. But there are 2 ways that researchers think this occurs. One is the library model, where it passively imagines libraries. And then the second model more aggressively imagines crime scenes. And we're going to go into these in more detail. So the library model. So you can picture your brain as like storing as a library, where it stores information just like books are stacked on shelves. So when we want to retrieve something, we use a command to pull out, to find a volume, to pull out that information, and once it's found, retrieved, we use that context and the memory is read like a book. So these memories can, it's often used soon after learning something new, like within minutes or hours or days. But then as time fades away, this memory comes to our second model, which is the crime scene. And this is more like, it becomes more of a collection of information, similar to like a collection of crime scenes of Sherlock Holmes. Does anyone watch the new Sherlock Holmes? Yeah, it's very good. You should watch it. So what happens to Sherlock Holmes? So Sherlock Holmes gets on a crime scene, and he has partial evidence. So there's fragments of data, just like when we're trying to pull something from our memory from a long time ago. And we use information to fill in the gaps with this information. And so our brain uses like pattern matching to help fill in these. So sometimes it can fill in gaps from something that we already know, or it can even make up memories, disturbingly. So why does it do this? And how can we make our long-term memory more reliable to help with less of the filling in the gaps, the more the pattern matching? Well, one method is called maintenance rehearsal. And and this is consistently to re-exposure of the same information. For example, with the activity, that first activity where we asked you to call, if you were to repeat that information, you would probably have remembered more. And so our brain can actually hold 7 new pieces of information in 30 seconds. That's why license plates are 7 digits and our phone numbers are 7 digits, because that's what we can recall within 30 seconds. We all remember September 11th. This is an event that affected our whole nation. Can some of you tell me where you were on September 11th?
Anatomy lab.
Anatomy lab.
Here.
Here.
VA.
The VA.
Selby Gardens in Sarasota,
Florida.
Getting pulled out of school.
Pulled out of
Middle
school.
Oh, we had school.
Yep. Me, I was in Spanish class, just stopped everything, pouring TV and watching the news. So why is it that instead of remembering what we ate for dinner last week, how can we remember this information that happened during that time? It's called elaborative rehearsal. So when you think about an event more, when you talk about an event with others, so this was in the news for a long time, we repeatedly heard this information, we talked about it, we thought about it for a long time. And because of this, we all remember where we were on 9/11, unfortunately. Another method to help us make our long-term memory more reliable is repetitions must be spaced out, not crammed. So we all probably look like this at some point in our lives. But when we get new information, that new information will either change its input or kind of wear down on the old memories that we have. This interference with wearing down the old memories can happen when we are cramming information, again, an overdose of information without breaks. But a lot of research has shown that when we get informations in fixed repetition cycles, over time, it can actually increase our knowledge base without interrupting what's already there. She studied a lot. She aced it and she remembered it a year later. All right, next I'll you guys know Pepe Le Pew?
Mm-hmm.
Oh yeah, he's one of my favorites. So, Pepe Le Pew. He sought eyes on, you guys remember her name? I had to Google it, I can't remember. Penelope was her name. He first laid eyes on Penelope. And what happened here was he got excited, his presynaptic sent a signal to his postsynaptic, and he thought about her. However, what if he never saw Penelope again? Never smelled her again, never had any more inputs? He would eventually forget about her. However, he did not forget about her. He had increasing smaller inputs with her, went on dates, had built more memories with her, and this increased the stronger connections he had with her. And this is called late long-term potentiation, such as when he first met her, it was early long-term potentiation. So the process of early long-term potentiation to, sorry, that's just a late long-term potentiation, is called synaptic consolidation. And with Pepe Le Pew and Penelope, they fell in love. This is also termed as fast consolidation because this can actually happen within minutes or hours. Maybe not so much love,
There's a
but
cat with
it's just an
paint
example.
going down her back. He mistook her for a skunk.
However, 2 neurons cannot just form our long-term memory. It's much more complex than that, as John led us into. And the hippocampus is involved in all memory formation. And so the hippocampus actually connects with, it's a 2-way connection with the cortex. And when the hippocampus breaks the connection into the cortex, that is when the memory is stored permanently. So, the inability to encode the long-term, the short-term information to the long-term so from the hippocampus into the cortex. The inability to do this is what Andrew Gray and me got. This is what Dory had. She couldn't take her long-term memory, her short-term memory, and encode it into her long-term memory. This is very similar to the story that we heard about Henry H.M. In the beginning, when he had that surgery done that affected his hippocampus. And when they studied him more, they actually found that he couldn't even remember stuff years ago. 3 years ago, they were asking him things that happened in his life, and he could not remember. However, he could remember everything, all the events in his childhood before 11 years of age. So this actually showed us that the information from long-term storage from the hippocampus into the cortex, where our memories are stored, can take years. However, we do forget stuff. Our brains are wired to forget irrelevant information that may be beneficial to our survival. So forgetting, we may have tips of the tongue, lapses, or brain farts, as I like to call them, absent-mindedness, blocking habits, distribution bias, suggestibility, but all this is our way that we can survive, to make room for prioritize critical information to our survival. So forgetting also allows us to prioritize. All right. From activity 2, when we break you up into left and right. I want everyone to write down how many words you remember. Was it? Okay, we'll give you about 30 more seconds to write down all the words you can remember.
So right side of the room, tell us what you were tasked with when you saw the words.
Looking for diagonal lines.
Yep.
There were 12 to 15, depending on how you interpret ours.
Good job.
All right, we're going to find out the left side in just a minute.
I remember there were 9 words.
I wrote down 8.
All right, so Frank,
I
you were
can't
on
remember the 9.
Were you,
You're on
I'm on the right.
You're on the right, and you actually remembered 8.
Did you write the word down?
Yeah.
On the,
All right.
Well, you do want me to write them down? Just now, you said to write them down.
Yeah,
you were on the
write
right
it down.
side. You were on
Oh,
our
write it
side?
down now.
Yeah, he was, because he couldn't decide
Oh,
who
did you write it
was
down?
There were
Yes.
9. I don't remember.
All right.
3.
Stop writing.
1.
Okay, so how many words did you write, Lucas? None.
1.
Matt? 1.
3.
Rainford?
Oh,
1. Chris? None. Dr. Selesky, you said
3.
All right, 1.
1 correctly.
1.
I didn't.
Oh,
You made up words.
Frank, and how many you had?
I got 8. I forgot whether.
All right, Frank is our.
But you said
Good
that.
outline.
But you wait. You said the diagonal. So I only picked the letter, and then I added the word later. Apple has a diagonal in it. That was the the clue, right?
Well, you just
You
had to
said-
count the diagonal lines. All right, so, and we'll go over that in just the left side. So Janice, 6.
5.
5.
So I thought they all had a diagonal.
1.
They did, yeah.
1. 5. Okay.
They had a different memories.
I was on the left. Well, I didn't
Oh, Teresa,
understand
yeah.
what the instructions, because you didn't
She was
have
on the
it
left.
for
She was on the
Likert
left.
scale. You didn't say what, how to rank.
Greg, you got
All
it.
right.
Oh,
So
no.
here's, so left side definitely
6.
got more, like, so left side was asked to think about the meaning of the word. So similar to how Dr. Freelander was saying that she made the word, that knows nonsense words into animals, that's what made it meaningful to her. So we actually asked them to rate on a scale 1 to 10 how much you liked or disliked the word. So by adding meaning to a word, whether it be the scale or something else with animals, it makes it more meaningful and therefore you tend to remember more. However, with the right side, we asked them to determine the number of letters that have diagonal lines in them and the number of letters that do not. So they just looked at the word and they were counting different lines and they tend not to remember as many words. Frank's an exception. He's the outlier.
I didn't do it right, though.
No, you did it right.
So some key points that we want you to take away with this. It takes years to consolidate a memory, not minutes, hours, days, but years. So what you learned in the first grade is actually not even formed until your sophomore year of high school.
What?
That's how they get you on the high smart and fifth grader. Medina's Dream School. So Medina was the author of Brain Rules. And his vision of how school or learning actually is that the school is one that repeats what was learned, not at home, so not taking learning it and then going at home and doing homework, but actually during the school day, 90 to 2 hours later, repeat the what initial learning occurred. Our schools are currently designed so that most real learning has to occur at home, which is several hours after they learned the initial information. So his is almost like you spend 30 minutes learning one subject, then you spend 30 minutes learning another, and then a third, and then you repeat that first one, that second one, that third one, throughout the day to help repeat to remember. So, how do you remember better? Repeated exposure to information, and specifically time interval, provides the most powerful way to fix memory into the brain. So again, repeating, spacing it out more. And then forgetting. Forgetting allows us to prioritize events, but if you want to remember, remember to repeat. All right, any questions? Any minds like, wow? So today we learned Brain Rules 5 and 6. Short-term memory, repeat to remember, and long-term memory, remember to repeat. Our next session will be on the generation